Okay, welcome to the second installment of the Finite Semester 1 review. And it looks like we're ready for number 26. It says, find the odds in favor of getting a sum of 9 when two fair dice are rolled. So odds is different than probability. When we're doing odds in favor of, we're comparing a positive outcome to a negative outcome. So in favor of would be to get a sum of 9 versus not a sum of 9. That's how we're going to set this up. So when we roll two die, there are 36 outcomes, and we just want to figure out which one's going to give us a sum of 9. We really don't have to list them all. I mean, you can start to think, okay, if I rolled a 1, would I get a sum of 9? Would it be possible with the second dice to get a sum of 9? And the answer is no. The biggest sum would be 7. If you did 2, no. If you did 3, yes, you could get a 3 and a 6. If you had a 4, get a 4 and 5 would give you 9. If you rolled a 5 on the first, a 5 and a 4. And if you rolled a 6 on the first die, a 6 and a 3. So there are 4 different outcomes where you're going to get a sum of 9. So that would be 4. And since there are 36 outcomes altogether, the number that's not the quantity that's not a sum of 9 would be 36 minus 4, which is 32. And even though it's not written as a fraction, it has a colon there, we still should reduce that, and we're going to get 1 to 8 is the odds. Okay, number 2, that's a little bit longer problem. You can use substitution to solve that system of equations. So I'm actually going to go to a separate page to do that. Okay, so I wrote the problem down, and we're going to use substitution. So what I want to do is take one of these equations that has a variable with a coefficient of 1, and I'm going to solve for that. The first equation it has a 1z, so I'm going to get z by itself, subtract 2x, subtract 3y, and then I have plus 9. So that's what z equals. Then I'm going to take the expression that z equals, and I'm going to substitute it in where I see z in the other two equations. So I would have 5x minus 5y minus z, which is negative 2x, minus 3y plus 9 equals negative 29. And for the second equation, 3x plus y plus 3 times z equals 9. And I need to simplify both of those equations. So that's going to give me 5x minus 5y, and then distribute the negative, so plus 2x plus 3y minus 9 equals negative 29. Or, simplified a little bit further, would be 7x minus 2y, and then I'm going to add the 9 to the other side. It gives me negative 20. Okay, then I'm going to do this equation. Let's see, I've got 3x plus y, and then I'm going to distribute the 3, so minus 6x minus 9y plus 27 equals 9. And simplify that one. So it's negative 3x minus 8y, and subtract 27 is going to be negative 18. Okay, so I'm going to take these two, and I'm going to solve that smaller system of equations, which is 7x minus 2y equals negative 20, and negative 3x minus 8y equals negative 18. I'm going to take this top equation and multiply it by 2, which is going to be 14x minus, multiply by, not 2, by 4, which is going to give me 28 x minus 8y equals negative 80. And I have two like terms. I'm going to subtract those columns. So I have negative 3 minus 28 is negative 31. X, my y's will cancel, and negative 18 plus 80, because minus negative 80 is plus 80, equals 62. And I'm going to divide by negative 31, and I get x equals negative 2. That's just the x. Now we have to go back to solve for the y. I'm going to use this guy here to help me with that, and I have negative 3 times negative 2, which was my x, minus 8y equals negative 18. That's 6 minus 8y equals negative 18. I'm going to subtract the 6, so that's negative 8y equals negative 24. And y equals 3 then. So I've got my x and my y. I'm going to go back up and grab my z equation up here at the top. Which z equals negative 2 times x, which is negative 2, minus 3 times y, which is 3, plus 9. So z is 4. This is my ordered triple of negative 2, 3, and 4. So see, it's quite a long process to do substitution. Okay, 28, 29, and 30 you can solve using any method you want. You can graph them, you can use substitution, you can use elimination. The easiest way to solve a system of equations, if you have two unknowns, now 3 unknowns you can't graph, but if you have 2 unknowns, just graphing them and finding their point of intersection. Wherever their intersection is going to be your solution. So let's take 28 here for an example of what it would look like if we did graphing. Okay, so what I did is I put both of these equations in Desmos, and I'm going to show you what happens. So this is for number 28, and I'm going to show you the first equation there, and you'll notice, I want you to take a really close look here, that that's a red line. And then when I put the next equation on, I don't see an intersection, I don't see where they crossed over, but I do see that my red line changed to blue. What that really means here on Desmos is that they're the equation of the same line. And so for that one I would have infinite solutions. Another thing that could happen if you're solving these by hand is if your variables get eliminated, but you end up with a statement where it says something like 0 equals 0. It doesn't even have to be zeros. It could be 3 equals 3, 4 equals 4, it doesn't matter. But it's a true statement. When we get a true statement, that's going to give us infinite solutions. Now let's say our variables were eliminated and we got something in the end that looked like this, 0 equals 3. Well, that's a false statement. We know that that's not true. And when you get a false statement, that's no solution. But in the case of this particular problem, the lines overlap, and so we have infinite solutions. Okay, this one's actually number 29, and I went ahead and did this because this one actually is going to have an intersection. So I put my equations in. Here's my first equation. You can see that I have a red line. And then here's my second equation, and that blue one's going to come across. So this time that they do intersect each other, and I can just click on the point of intersection, it's thinking about it really hard. There we go. Okay, so there's my point of intersection. It is at negative 3, 2, and that's my solution as well. Okay, this next one's going to be number 31, and it says describe the feasible region, and it gives you a set of inequalities. So what I want to do for that problem, and again this is number 31, what I want to do for that problem is I'm going to put my inequalities that are given into Desmos. So x plus y is less than or equal to 19. A little too many ones there. There we go. And let's see, x plus 2y is greater than or equal to 4. And the third equation, 2x plus y is greater than or equal to 4. Obviously I'm not seeing the whole thing, so I'm going to zoom out a fair bit. And here's my equation, or my solution, sorry. This is a bounded region. We've got a corner point there, maybe. Alright, so our bounded region is this darker green section right here. And we say it's bounded because you can see it has 3 sides and it's a triangle, so it's all enclosed in one. That's an example of a bounded region, and that would be my solution there. If I have an equation where an inequality, I guess, or a system of inequalities, where I'm bounded on one side, but I have at least one side that's open and goes on to infinity, that's going to be unbounded. So this one is bounded below. And this would be where it's bounded, along here, and then all of that is open at the top, so it just keeps going on forever in that direction. So that's an example of something that's unbounded. You could also have it bounded above, where we've got a top end, but there's no minimum value. Okay, it just keeps going down and down and down. That's what it means to be bounded. Number 32 is actually an example of an empty system, and we'll take a look at what that means. So this is 32. Just like I did on 31, I'm going to graph my inequalities. And I have x plus y is greater than or equal to 3. And then my second equation is x plus y is less than or equal to -10. For this one, you can see that there's actually no overlap. There's this big hole in the middle. We've got a shading above and a shading below, but there's no overlap between the two. And that's an example of an empty system of inequalities. And that would probably help you answer number 33. Okay, 35, for that one we're just going to set up a matrix for that. We don't have to even do anything with it. A bakery sells 3 types of cakes. Cake 1 requires 2 cups of flour, 2 cups of sugar, and 2 eggs. Cake 2 requires 4 cups of flour, 1 cup of sugar, 1 egg. Cake 3, 2 cups of flour, 2 sugars, 3 eggs. And we want a 3x3 matrix showing the required ingredients. And it tells us that it wants the cakes to be on the rows and the ingredients to be in the columns. So I'm going to label it like that. I'm going to say there's my cake, and then I've got my ingredients. Okay, so there's cake 1, cake 2, and cake 3. And And then we have flour, sugar, and eggs. And I'm just going to put how much of each. So cake 1 takes 2 cups of flour, 2 cups of sugar, and 2 eggs. Cake 2 has 4 cups of flour, 1 cup of sugar, and 1 egg. And cake 3 has 2 cups of flour, 2 cups of sugar, and 3 eggs. And that's my 3x3 matrix, and that's it. Number 36, you just have to graph the equation. This is, when it says x equals -5, it just means it's a line that goes through the x-axis at -5. So it's a vertical line. And we go right through -5. That's simple. 37, I mean, you could put that in Desmos and see what it looks like, but you could also put it in slope-intercept form. And that's where we solve for y, and I have 2y equals -7x plus 2. Divide by 2, and y equals -7/2 x plus 1. And so I would find 1 is my intercept, and go down 7 units, and to the right 2, and that's going to be my second point. And then I would just draw a line through those. So there's my line. Number 38, it says to transpose. When you transpose a matrix, that just means that the rows are going to become columns and the columns are going to become rows. So row 1, which is 19, 2, 8, and 19, is going to become column 1. 19, 2, 8, and 19. And row 2 is column 2, so -1, 2, -3, and 5. And row 3 is column 3, 6, 7, 9, and 2. And that's my transpose matrix. If I was trying to do it with a calculator, I could just put A to the T. Number 39, it says use a graphing calculator to find the matrix product and or sum. We're just finding a sum here. Honestly, you don't need a calculator. All we're doing is adding like elements, or elements that are in the same location. So basically I would add whatever's in row 1 column 1 to row 1 column 1 and B. Same thing, row 1 column 2, row 1 column 2, and just adding like parts. So in my sum, A plus B, my first element then would be -6 plus 4, which is -2. My second element would be -14 plus 17, which is 3. 18 plus -6 would be 12. And first row, fourth column, would be 18 plus 3, which is 21. And then I would continue that with the other rows. Number 40, we want the union rule, so you have to remember what the union rule is. We're going to take the union of A and B, and that's equal to the number in A plus the number in B minus their intersection. So we'll fill that in. The number in the union is 63. We don't know what A is, so we'll just leave that. Plus B, the number in B, which is 36. Minus the intersection, which is 7. So do a little simplifying. We have 63 equals the number of A plus 29. And then when you subtract 29 from both sides, you get the number in A is 63 minus 29, which is 34. And number 41, it says let P represent I eat too much, Q is I exercise, and R is the food is good. And we're going to write a compound statement in symbols. So the food is good, that was represented by R. I eat too much was P, and I exercise is Q. So this first part, the if, that's R and P in parentheses. Then, so you have to have a little arrow, Q. So that's what it would look like. All right, number 42, it says find an equation of the least square line. That's the line of best fit, or y equals mx plus b, and that just means a line that goes through the given points that is closely matches it as possible. So the points may not all be in a straight line, but the equation of the line is going to represent something that's linear. And then I'm going to use Desmos for that. I have to put it in their correct format, y sub 1, and the little squiggle, mx sub 1 plus b. So I'm going to put my table in Desmos. I'm going to put that equation in there and figure out what m and b will be. Okay, so I went ahead and put the data in from our table, and if you're don't remember how to do that, you just go up here to the little plus sign and you're going to click on table and it's going to add a table for you. You just want to make sure that your columns are listed as x1 and y1, because that's how we're going to enter our equation. We wanted a linear equation, so we're going to do that. We're going to do y sub 1. And then to get that little squiggle sign, that tells Desmos to write the equation for us. And so we have a little squiggle, m x sub 1 plus b. Okay. And what that does is it's going to give us the m and the b for our equation. So the equation, the line of best fit, or the least squares line, would be y equals 0.93011 x plus 19.401. So that's the equation of my line. There's a question here in a little bit, and while I'm on this, that asks us about the correlation coefficient, and not that you need it for this one, but it's this number right here, this R, and we talked about it briefly. The correlation coefficient just tells us how strongly a predictor the equation of our line is going to be for data in the future. So if we wanted to know what happens if x is 70, would that equation be a good indicator of an accurate value for y? And the closer it is to 1, the better it is. But that's our correlation coefficient. So it's pretty close to 1. So that's a strong correlation. Okay, 43. That one just asks us to graph the linear inequality. We're going to graph it like we have the line x equals 6, but we do have an inequality, so that's going to be, and it's not a less than or equal to, it's a less than, so we're going to do a dotted line through 6. But it's a vertical line, should be dashed going through 6. And then less than 6 is shaded to the left. Number 4, we've got a logic statement about circuits. So what we want to do is we want to go from the left side and enter the circuit, and then go on the outside. But when we enter it from the left, we see that we have two options. We can either go up and go through P and Q, or we can go down and go through R and S. So that's exactly what we're going to say. We could do P and Q, or R and S. Number 45, convert the inequality into a linear equation. So notice it's an inequality right now, and we're going to do that by adding slack variables. And you may remember this is when we had several inequalities in a linear programming problem, we had to add slack variables. And what that does is adds to the left side of the equation some amount so that the equation is actually going to equal 114 and not possibly be less than. So we have x sub 1 plus 9x sub 2 plus 7x sub 3 plus a slack variable is equal to 114. P. Number 46, let P represent the statement 7 is less than 8. That's true, so I'm going to put a little t there. Let Q represent the statement 5 is greater than 2 and less than 6. That's a true statement as well. And R, 3 is less than 2. That one's false. So I'm going to go through in this statement and I'm going to replace the P, Q, and the R with true and falses. So I have not P, which is P and R. P was T and R was false, so not true and false. And Q is also true and R is false. Okay, so I ended up having a not true and false and not true and false. So that's equivalent to, and we just work this like it's an order of operations problem. We're going to say what true and false has, what value that is. So in parentheses that would actually be false, because for an and to be true they both have to be true. And not false. Well, not false is true. So now we've got true and true. Two trues make a true. So the final value is true. Number 47, we just want to know if the inverses, if they're inverses of each other. So I'm going to call this A and I'm going to call this B. And basically I want to know, is the inverse of A equal to B? And is A equal to the inverse of B? What we can do for this is we can use a matrix calculator. And I'm going to go to one here and I'll show you how to work that out. So actually I'm going to go up here to Canvas and I'm going to go to Finite, and I put a link on there for you if you go to the modules. You just go all the way down and it says Finite Calculator links, and you click on that and it says Matrix Calculator. This is a super easy matrix calculator. And so I'm going to put in my A matrix. My A matrix is a 2 by 2, and these little sliders make your matrices bigger or smaller. And so I'm going to make it a 2 by 2 here for A, and I'm going to put those values in. And we have 9 and -2 and 7 and -2. And I'm going to do the same thing for B. B is also a 2 by 2. And I have 1/2. And another 1/2. And -7/4. And -9/4. So I want to know if they're inverses. So I'm going to take A inverse B, or A inverse. You can just click right here and see if it matches up to B or not. Well, I see that A inverse is 1/2 and -1/2, and positive 1 3/4 and -2 1/4. My signs are not the same, so A inverse is not equal to b. So the answer is no, they're not inverses. So we can tell that right away. Okay, 48, it says evaluate the function as indicated. We want to know what f of 0.8 is. All that's wanting us to do is replace the x in the function with 0.8. So f of 0.8 is equal to negative 8.8 times 0.8 minus 1. I don't know how many times I see this, but this is not f times 0.8. Okay, this is the function f, and it says replace the x in there with a 0.8. That's just the name. This is what we're doing over here. So you're going to take negative 8.8 times 0.8 and subtract 1, and you're going to get negative 8.04. So when x is 0.8, the output, or f of x, is negative 8.04. Okay, number 49, it says write the negation of the statement, and remember that negation, if then, if p then q, is p and not q. So really we just have to identify what p is, identify q, and then we're going to rewrite it as p and not q. That's going to be the negation. So p was 7x plus 2y is greater than 15. And not q. So the answer, and so the answer is the ocean, the answer is not ocean. So that's how you need to do the negation. Okay, for 50, so our last one, one of the tricks you can do to figure out how to color your diagram is to put a number in each section. So I have on the outside, then I have a 2, maybe. Let's do that again. A 2, a 3, and a 4. And so 1, 2, 3, 4 is my universal set. A is 2 and 3, which leaves A prime to be 1 and 4. B is 3 and 4, which leaves B prime to be 1 and 2. And then I also need to know what the intersection of A and B is. That's just the points that they have in common. So set A and set B have a 3 in common. And then I'm ready to put everything together. So that A prime union A intersect B. So that's this and this. The union is just all of those points together. So I have 1, 3, and 4. And those are the sections that I'm going to shade. So I just leave that larger part of A out. Okay, that's our review. For the final, make sure that you bring your laptop so that you can use Desmos, and if you need to, you can use the matrix calculator. And you can have a note card. You can use front and back. It has to be a 3x5 note card. You can put anything you want on that, and you can use for your final as well. So happy studying, and I'll see you on the day that you take your final.